Hi girls. You'll have to forgive me, I'll be a bit clunky. This is the first time I've tried to do one of these. But I'm going to provide a video for the systems of simultaneous equations. We're looking for a situation where we can solve for a unique solution, for a situation where there are no solutions, and for a situation where there are infinite solutions. So in an exam question, you often get given a set of simultaneous equations, such as the ones here. Here we have ax plus by equals p, which is a constant, cx plus dy equals q. I'll first consider the situation where we may have a unique solution. We know when we're looking at equations of lines that if the lines are not parallel, then they will cross at exactly one spot. And this would provide us with a unique solution. With equations in standard form, such as the ones above, if we look at the ratios between the coefficients of the x and y variable, if they're the same, then the lines are parallel. If they're different, then the lines will be not parallel and therefore provide a unique solution. So if our ratio of A to C does not equal our ratio from B to D, then the equation will have a unique solution for the variables x and y. The next scenario we want to look at is if we want no solution. Oh, I can't spell. Sorry about that. Oh, hang on. No solution. In this case, for our x and y variables, our lines would need to be parallel. In this situation, there is no x and y values for which the lines meet, and therefore there is no solution. For parallel lines, the ratios of our coefficients would equal each other. So in this case, our ratio from A to C equals our ratio from B to D. But we don't want the ratio of our y-intercepts to equal each other. We want a different intercept. So it does not equal the ratio of P to Q. Our final scenario is where we have infinite solutions. For there to be infinite solutions, we really want two lines, one of which is just simply a straight multiple of the other. One line is a multiple of the other. Infinite solutions really the same line. For this to happen, the ratio of the coefficients, again, need to be equal, but also the intercept would need to be equal. So there you are, there's our 3 examples. I'll show you what it means as far as an exam question is concerned on the next page. Thank you. Hi girls. As promised, here's a worked example, similar to the one we did in class, where we're looking at we need to find an infinite number of solutions for this set of equations. So we know that if we want an infinite number of solutions, we want all the ratios to equal each other. So we want a over 2 to equal -5 over a plus 11, and we also want that to equal a plus 4 over -6, which we'll consider later on. So let's just solve this. A plus 11 equals -10. Expand out, a squared plus 11a equals -10. A squared plus 11a plus 10 equals 0. A quick factorising, a plus 1, a plus 10 equals 0. So a equals -1 or a equals -10. In this case, what we want is to double check or substitute in these 2 solutions that we've just got and check which one of these satisfies the third ratio. So when a equals, oh sorry, didn't mean to keep it as yellow. Rub that out. Sorry about that. Okay, so when a, oh no, I'm gonna, oh, here we go. When a equals -1, what would we have? We'd have -1 over 2 equals -5 over 10. That's correct. Does that equal, oh, what have we got here? 3 over -6. Yes. So infinite solutions a equals -1. I'm just going to put a box around there so we know that for sure. Now I'm going to check when a equals -10, because it might work. So a equals -10, what do we get? -10 over 2 equals -5 over 1. They both equal -5, don't they? What about here? We get -10 plus 4. That is -6 over -6. No, it doesn't equal that. So therefore, our infinite solution of this would be no solution. So our infinite solution is a equals -1. In the exam, you'll often get a double point question. So here they've asked to find the value of a where there's an infinite solution. But also part B is asking you where there's a unique solution. So we know the unique solution happens when the ratios do not equal each other. We've already solved this, so we know that this does not equal -1 or -10. How could we put that in our thing as a solution? We'd say A is an element of any number of the reals except -1 or -10. I'm just going to put a box around that so that you can see it. See if we can see the whole solution there. There you go.